Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Asimology. In the previous tutorial, we discussed some basic concepts about the chemistry, matter, mixtures, compounds, atoms, and molecules, etc. In today's tutorial, we will briefly recap mixtures and compounds, and we will extend our discussion to separation of mixtures, various techniques that are used to separate mixtures in solid, liquid, or gaseous state. Among them, we will discuss about filtration, reverse osmosis, distillation, sedimentation, sublimation, recrystallization, evaporation, chromatography, and centrifugation. So we discussed in the previous lecture about compounds, but to recap, compound is a substance that is made by a chemical combination of two or more elements in a definite proportion. Here we use two critical points. One is the chemical combination and second is a definite proportion. So whenever these two conditions are fulfilled, and two substances combine together fulfilling these two conditions, the newly formed substance is called compound. So compound is again a pure substance, but it has two or more elements in it. The compound can be decomposed again to the constituent elements by applying certain suitable methods. To exemplify, we can take the example of burning hydrogen in the presence of oxygen. It will form water. So water, H2O, is a compound. It contains two elements. One is oxygen and second is hydrogen. So these two compounds, when chemically combined together, it forms a new substance which is called water, and water molecule is a compound molecule. It has two substances, hydrogen and oxygen in it, and there is a fixed ratio. There will always be two hydrogen and one oxygen atom in a water molecule, regardless of its source. It doesn't matter from which source you are getting water, whether you are getting water from rain, from a pond, from river, from sea, or other underground water. All these sources will give you water containing two hydrogen atom and one oxygen atom in its molecule. So there is a fixed proportion, that is the ratio of two hydrogen to one oxygen in the water molecule, and it has two elements, the atoms of hydrogen and oxygen that are combined, that are attached to each other through some chemical bonds, chemical forces. So this compound can also be reconverted to its constituent elements by applying certain methods, like electrolysis of water. When you pass electricity through water, it is decomposed into constituent elements, hydrogen and oxygen, and the ratio, the macroscopic composition you are getting from the electrolysis of water correspond to the molecular composition. You will get 11% hydrogen and 89% oxygen by mass from the electrolysis of water, and this ratio can be obtained theoretically from this stoichiometric equation. How to calculate this ratio by mass, I will show you in another video. In contrast to compounds, mixture has different properties. Mixture is a physical combination of two or more substances in which each substance retains its chemical identity. Now again, the critical terms used in this definition are physical combination. Mixture has physical forces. Component in the mixture has physical attraction. There is no chemical change involved. is the result of combination of these elements. So whenever there is no chemical change, the elements, the constituent components will retain its identity. And you can prepare mixture in any composition. So the composition is variable. In this example, you can see each substance. Like you can take the example of a cookie. It is the mixture of the dough and many ingredients in it, and it has some pieces of chocolate embedded on its surface. So the chocolate is one of the ingredient of this mixture. It is a heterogeneous mixture. So the chocolate retained its color and its flavor and many of its properties. Among homogeneous mixture, you can take the example of sugar dissolved in water. So you can make mixture of sugar in water in any composition. You can add 1 spoon, half spoon, 2 spoon. You can prepare any composition of this mixture. And in this mixture, after resolution, the sugar retain its properties like the sweetness. Although its phase is changed from solid to liquid, it changes its physical state, but it retains its other properties like sweetness, the taste, flavor. So you can compare compound with the mixture. In the compound, there is a chemical combination between the constituent elements, while in mixture, the combination is physical. So physical combination allow you to separate the components by various physical methods, easy methods. If the combination is chemical, you will need special or advanced techniques to break up this bond and remove the components from each other, separate the components from each other. And as there is a chemical bond involved, each component lost its identity and it forms a new compound. So compound is a new substance which has none of the properties of the constituent components or elements, while mixture is the physical combination of the substances, so each component retain its identity. And in compound there is a fixed composition, a fixed ratio between the elements, while mixture can be prepared in any desirable composition. So these were some basic key points about compounds and mixture. Our target for today's tutorial is about separation techniques that are used for separating mixtures. So the topic of today's discussion is separation of mixtures. In this picture you can see we have a mixture of gold and iron fillings, small particles of gold mixed together with small particles of iron. You can see each component has retained its properties. Like color is a property, and you can differentiate iron particles from gold particles by looking at the color of these particles. So each component has retained its identity. By taking advantage of the difference in their properties, you can separate the mixture. So let's say, for example, by picking the iron particles from this mixture, you can separate the two components. But that will be a very laborious job. Instead, you can take another property is the basis for differentiation, the basis for separation, like magnetism. So iron is a magnetic element. So by taking the advantage of these magnetic properties, by using a magnet, you can separate the iron particles from this mixture. Is iron particles will be attracted towards the magnet, and the gold particles show no attraction towards the magnet. So magnetism is the property of iron particles, and by taking advantage of this property, you can separate the mixture. You can separate the mixture easily. You can also separate this mixture by taking advantage of some other chemical difference between the two elements. For example, solubility. So iron can be dissolved in some acids while gold is not soluble in acids. So there is difference in the solubility of the two elements, and this chemical property, that is the solubility, can help you to separate the mixture. So when this mixture is added to some acids, appropriate acids, it will dissolve the iron fillings and the gold particle will left behind. So by filtering this mixture, the liquid mixture, you can get solid gold particles on the filter paper, and iron dissolved in acid is the filtrate. So these are common examples. Here are a list of various methods that can be used for separation of mixtures in gaseous state, in liquid, or in solid state. Sublimation is a process in which a solid goes directly to gaseous phase upon heating. Normally, when we heat up a solid, it goes to liquid state. And when this liquid is heated up, it goes to gaseous state. It gives you vapors. But some substances, when they heat up, they can directly go to solid state by passing this liquid phase. So those substances which give you gaseous phase upon heating, those solid substances are called sublimable. When a sublimable substance is heated up, it goes to gaseous state. So if this sublimable substance has some impurities in it, if it is impure, you can purify this sublimable substance by taking advantage of its sublimable property. You heat up this substance, it will goes to vapors, and you collect the vapors and recondense it. Upon cooling, it will condense to form the solid again. So you can purify sublimable substances from by removing impurity from this substance using the sublimation property or sublimation process. Another is recrystallization. Recrystallization is also useful for purification of solids. If a solid has some impurities in it, you dissolve this solid in a suitable solvent. You heat up this solvent. You know, with the increase in temperature, the solubility of substances increases. So when you boil this solution, it will dissolve the solid. The solvent will dissolve the solid to its maximum capacity. And when you filter this solution, the solid impurities will be retained by the filter paper, and you will get filtrate without solid impurities. And upon cooling, when you cool down this solution, the solid will recrystallize out, and in this way you can purify solids. So dissolution, filtration, and cooling give you recrystallization of the solids. Evaporation is another process which can be used for purification or separation of mixtures. For example, you have a liquid. So liquid evaporates at all temperatures. Evaporation takes place at all temperature. However, with the increase in temperature, evaporation rate increases. More liquid goes to vapor state at higher temperatures. So when you heat up a liquid containing some impurities that are not separable by any other mean, so each liquid has different vapor pressure or rate of evaporation depending upon the intermolecular forces in it. So upon heating, the liquid will go to vapor state, and these vapors, if condensed, you can get the liquid again. And the solid impurities or any other soluble impurity, it will left behind in the container. Another process which is very commonly used in laboratories, and we use this process at home for separation of solid impurities from liquid. So it is a simple process. You pass the mixture through a filter paper, or in home we use cloth for filtration to remove suspended solid particles from liquid. Distillation is another important separation technique. In distillation process, you heat up a mixture of homogeneous liquids. Homogeneous are soluble liquids. When two liquids combine together, they form a homogeneous mixture, and you cannot separate this mixture through filtration process. So distillation is effective method to separate these two liquids based on difference in their boiling point or rate of evaporation. We can define distillation simply. The process of evaporation followed by condensation is called distillation. Evaporation followed by condensation is called distillation. Let me give you an example. If you dissolve salt in water, so salt become mixed up, or it completely dissolves in liquid in water, and you cannot separate salt from this water by filtration. So if you heat up this liquid, the water will evaporate, and when you condense these vapors by passing like cold water around this condenser, the vapors will condense and you will get again pure water in liquid form. So in this process, you see, first we evaporized the liquid, that is evaporation, and it was followed by condensation. So evaporation followed by condensation is called distillation. Distillation can be done in various ways, and one of them is vacuum distillation. So vacuum distillation is also known as distillation under reduced pressure. It can either be a steam or fractional distillation. Fractional distillation is the same, but we use a fractionating column to separate volatile liquids based on their difference in boiling points. Chromatography is another technique used for separation of liquids, miscible liquids, and this technique is based on the difference in the abilities of substances to adhere to the surface of solids. Partition chromatography is a common example in which separation is based on the difference in the solubility of the mixture components in a particular solvent, that is mobile phase. In chromatography, we have two phases. One is the stationary phase or the solid phase, which is not moving, and one is the mobile phase or movable phase, which is moving. In this picture, you can see we have a solvent taken in a container, and we have a solid piece of paper dipped in this solvent. So here you can see a drop of ink put on this piece of paper. So this ink is actually a mixture of different colored liquids, mixture of liquids having different colors. You can separate this ink to its constituent components, to its constituent liquids by using chromatography techniques. So when you dip this piece of paper in the liquid, the suitable solvent, the solvent will be taken up by this paper, and using the capillary action it will goes upward, and it will also take away the ingredient of this ink mixture with itself. So again, the rate of flow of each component of this ink mixture is different, and it depends upon several factors. We exemplified the solubility of this each ink component in the ink mix in the solvent. So solubility of each component of this ink mixture is different in this particular solvent. So having component having higher solubility will travel longer than having lesser solubility, and then again having lesser solubility. In this developed chromatogram, you can see distinct colors, regions of distinct color, which has been separated from this piece of from this drop of ink mixture. So ink mixture can be separated to its constituent element or constituent compound liquids, constituent uh, liquids having different colors based on chromatography. So chromatography is also called writing of colors. Chroma means color, graphy means writing. It is the writing of colors. You can differentiate substances of the mixture based on their color. Another method of chromatography is adsorption chromatography. In adsorption chromatography, separation is based on the attraction or adsorption ability of the mixture component and the stationary phase. Sedimentation is another process used for separation of solid impurities from liquid. If the particles are larger in size and you allow the liquid containing these solid impurity or solid particles, the solid impurities due to gravity will settle down after some time in the bottom of the container, and you can decant the upper portion of the clear liquid into another container. So sedimentation is the process in which a liquid mixture containing solid impurities is allowed to stand undisturbed, so the solid particles settle down and the upper liquid, clear liquid, is decanted. Centrifugation is another important separation technique. If the particle size is larger enough uh, that can settle down by itself, we use sedimentation. If the particle size is smaller than this region, we use filtration technique. And if particles are extremely smaller that are not separable by filtration, so in that case we use centrifugation. In this picture you can see here is a mixture of solid particles, or it can be a liquid of higher molecular weight like protein or DNA molecules, molecules of larger molecular weight. You can separate that from low molecular weight substances or from liquids. So in this process we spun this tube containing the mixture at higher speed. Like you can see, the screen shows 13,500 revolution per minute. So at this much high speed, the particles, the high molecular weight substances will settle down at the bottom, and the low molecular weight liquid will form a top layer. So you can decant this liquid and you will get solid or higher molecular weight substances at the bottom of this centrifuge tube. And this machine is called centrifuge machine. Reverse osmosis is another important technique that is used for purification of salty water or seawater to make it drinkable. You might be aware of the RO plants or reverse osmosis plants that are used at homes for purification of drinkable liquids, or at industrial level you get bottled water, and when you if you read the label it might say somewhere that it has been purified with the RO plant, reverse osmosis plant. So in the reverse osmosis, what we do actually, we apply pressure and the liquid molecules move from region of its higher concentration to a region of lower concentration. In this example, if you see, we have a salty water having high concentration of salt, and there is a semi-permeable membrane. So when we apply pressure over it, the water molecule will move across the semi-permeable membrane, and we will get fresh water or pure water in this column. So in this case, we use a semi-permeable membrane. This membrane will allow the molecule to pass through, but it will not allow the ions or solid particles. So ions cannot pass through the pores of the semi-permeable membrane, but water molecule can pass through. So we get pure water molecule on the other side, and this process is done under the high pressure, higher than the osmotic pressure.